What's up, calculus students? Second homework video coming at you. We're solving equations. So what we're looking for is angles as our solutions. Your answers aren't going to be root 3 over 2 or 1/2 anymore. Answers are going to be, some pi over something. Um, Two ways we can handle this. All right. I'll show you both ways. You could either think about one of your triangles, 30, 60, 90, short, 30, 60, 90, tall, 45, 45, 90. Try to pick out the correct one. Based off the trig function, you are looking to find your angles to that equals this ratio. So we got cosine here, and cosine's always talking about the adjacents, which are always the horizontal distances or the x distances. Okay, so we got to think what kind of triangle has an x distance of 1/2? We should be thinking the taller 30, 60, 90 triangle, that triangle, where it's a 60-degree reference angle that creates the shorter side on the bottom and the longer side here. Okay? Start with that. And then using the mnemonic, all students take calculus, realize that cosine is positive in the first quadrant, where all the trig functions are positive, or the fourth quadrant, where cosine's positive. And then you think, okay, I need the 60-degree angle here, and I need the 60-degree angle in reference to the x-axis here. It says draw the location of the angle, right? The reference angle is created when needed. What I'm saying is like kind of what I just did here. Just kind of draw where our solutions are. And that's kind of like repeated here. Draw the locations of the solutions on the coordinate plane. So now we need the correct radian measurements with 60-degree angles. You got to remember any pi over 3 creates a 60-degree reference angle. Any pi over 6 creates a 30-degree reference angle. It's shorter. It's a smaller angle because you're dividing by 6 versus dividing by 3. And then we should all be comfortable with the pi's over 4 creating a 45-degree reference angle. So I want the pi over 3 located in the first quadrant. It's pi over 3, just by itself, that arc. And then what's this pi over 3? Well, we could go 3 pi over 3, 4 pi over 3, 5 pi over 3. Or you can go all the way around to 2 pi, all the way around to 6 pi over 3, same as 2 pi, subtract a pi over 3, 5 pi over 3. So that's one way to do it. The other way is to just not use the mnemonic at all and really just focus on kind of understanding cosine, the value, and positive or negative. What I mean by that is don't worry about ASTC. Rather, say cosine. I'm just going to pretend like we didn't do anything. Cosine, horizontal distance, x distance is equal 1/2. Well, here is where cosine's positive to the right. And I want that length to be 1/2. And then you can think, well, in this 30, 60, 90, I'll have this triangle here, and I'll have this triangle here, where this cosine value is 1/2. Pretend like this goes out to the same spot. And then from there, you're like, oh, that's at a 60-degree reference angle, 6-degree reference angle, taller. And then from there, you get your solutions. Oh, that has to be pi over 3, 6 pi over 3 minus pi over 3, 5 pi over 3. So your two solutions for x between 0 and 2 pi are pi over 3 and 5 pi over 3. I'll kind of go between both of them as I go through these problems. So just ready for that. So let's do, the second way. Sine equals negative 1/2. Sine deals with the opposite in SOHCAHTOA. Opposite on a unit circle is always the vertical distance, so we're looking for a y distance that's negative 1/2. Using the second technique, we'll just say, okay, I want this distance right here, y distance that's negative 1/2. And then you think like, which angles create the triangle where that distance is negative 1/2? Now this is tricky because people sometimes like to create a triangle like that. I don't I don't want you to do that because we never create a triangle with the uh, the y-axis. It's always with the x-axis. So we want like our triangles like this, and we want this side length to be negative a half. And over here, you get what I'm doing, where this vertical side length is negative a half. Okay, and you should realize, okay, that's a shorter 30, 60, 90 triangle where our reference angle is 30 degrees. Reference angle of 30 degrees, we have a pi over 6. We just have to find the correct pi over 6 for this angle measurement and the correct pi over 6 for this angle measurement. How do we do it? Just a reminder, could have said this at the beginning. This is going in a positive direction with adding angles. This would be subtracting angles in a negative direction. Could have done that here too. Subtracted. So, I don't know, you start here. And again, we're looking for pi over 6s for this one on the right. What is this, pi? That's 6 pi over 6. Add a pi over 6, get to 7 pi over 6. 2 pi, 12 pi over 6, minus a pi over 6, 11 pi's over 6. So those are your two solutions for x. 7 pi over 6 and 11 pi over 6 between 0 and 2 pi. Okay? Let's do the other method. All students take calculus. Cosine, adjacent, horizontal, x distance. The x distance needs to be negative. So one is cosine negative. We're looking at this quadrant and this quadrant. What type of triangle has a cosine and horizontal of root 3 over 2? That's the longer side in a 30, 60, 90. So I want the x to be longer than the y. So I want the shorter 30, 60, 90 triangle, where the vertical side is 1/2 and the horizontal side is root 3 over 2. That's a reference angle of 30 degrees with the x-axis. So that's on a pi over 6. So I want the pi over 6 located here in the second quadrant and here in the third quadrant. Whoa. Okay. That's using this technique. You could have done the same thing with, I'm going negative root 3 over 2, longer than 1/2. So if this is 6 pi over 6, this is going to be 5 pi over 6, this is going to be 7 pi over 6. Subtracting going this way, adding going this way. 5 pi over 6 here, 7 pi over 6 here. Creates that triangle that we're looking for. We'll just finish it up there. Many of you can do this a lot quicker than how I'm doing it. All right, cosine negative root 2 over 2. Let's do the other way. So x distance negative, so I'm going to the left. Root 2 over 2 is created with our 45, 45, 90 triangle. So I want this 45, 45, 90 triangle. And I want this 45, 45, 90 triangle. Let's pretend like I'm going out a little bit further to the unit circle, or whatever. 45, 45, 90 triangle. We have that third pi's over 4. How do I know which pi over 4 it is? Well, here's 4 pi over 4, subtract a pi over 4, add a pi over 4. This would be 3 pi over 4 right here. This would be 5 pi over 4 right here. And those are my solutions. For x. Okay, sine, vertical, y distance, root 3 over 2. You can go here. Or maybe better is to say, okay, with y's in our triangles, I'm going to be going up. Okay, 2 locations where I'm going up more than I'm going over. That's tough. It's tough maybe to do that. Maybe I don't want to do that. Maybe I do stick with ASTC, but it's like I'm going up more than I'm going over. I should actually go right here. go right there. Because we want our tall 30, 60, 90 triangle. Okay, and you guys, pick which way works that you understand that makes sense. Whether it's using ASTC or it's kind of drawing the lengths. I think maybe ASTC might help, and maybe just starting with like, okay, when is the vertical side length root 3 over 2? Tall 30, 60, 90 triangle has a vertical side of root 3 over 2. Shorter side is 1/2. So these are at pi over 3s. The tall, because this is a 60-degree angle, opposite the longer side. So I need this pi over 3. This would be 1 pi over 3, 1 pi over 3 away from 0 pi over 3. And then you can either add a pi over 3 to get 2 pi over 3, add 60 degrees, or start from 3 pi over 3 and subtract 60 degrees. 3 pi over 3 minus pi over 3 is 2 pi over 3. All right, moving on to tangents. Tangents are tricky. I don't memorize like when is tangent this and when is tangent that. Not even I do that. I literally, in my head, think there's two options. Okay, we know that it's not going to be at a 45, 45, 90 triangle. Why not? It's because the tangent of pi over 4 is always going to be 1 or -1 because the opposite and the adjacent are the same side length. So really the two options to get root 3 over 3 are going to be your tall or your short, 30, 60, 90s. We got to figure out which one is that. Which one will opposite over adjacent or vertical over horizontal or y over x give us root 3 over 3. So let's see. Let's start with the tall, pi over 3, 60 degree. If I do opposite over adjacent, we know that that's the same as root 3 over 2 times 2 over 1, which is root 3. That's not root 3 over 3. This is fine. This is root 3 over 1. You don't rationalize this. The square root's in the top. That's not it. It's got to be this. Let's confirm. If the opposite's 1/2 and the adjacent's root 3 over 2, opposite over adjacent gives us 1/2 times 2 over root 3, which is 1 over root 3. And 1 over root 3 can be rationalized by multiplying the top and bottom by root 3 to be root 3 over 3. Okay? Great. So this is our winner. This winner is our 30-degree angle, our pi over 6 triangle. Now, when is tangent negative? ASTC. Tangent's positive in the first and the third, so that means tangent's negative in the second and the fourth. I want the 30-degree triangle created in the second and the fourth quadrants. So that's this pi over 6 here, and this pi over 6 here. And that's going straight up, obviously. Okay, so 6 pi over 6 minus a pi over 6, because this is 30 degree. I want our shorter triangles, 5 pi over 6. 12 pi over 6 minus a pi over 6, 11 pi over 6. Okay, it's close to 12 pi over 6. So those are my two answers, 5 pi over 6 and 11 pi over 6. That's the tangents are tricky. Tangents are tricky. Okay, we already did the work to know which triangle we're looking for. We already know that we get root 3 with the tall 30, 60, 90 triangle. So I'm going to go and just say like, okay, tangent is positive in the first and the third. Tangent's root 3 with the tall 30, 60, 90. When I do opposite over adjacent, it's root 3 over 2 divided by 1/2. So I want the tall one here where tangent's positive. And I want the tall one here where tangent's positive, creating it with the x-axis, right? So I need this pi over 3 and this pi over 3. This is 1 pi over 3. This is going to be 3 pi over 3, right? Add a pi over 3. This must be 4 pi over 3. Okay, this is how I do this. I don't have anything else memorized, any other techniques besides like use the triangles, use SOHCAHTOA, know where the radians are located. All right, whenever we deal with a reciprocal function, cosecant, secant, cotangent, I always like to just like flip it. If cosecant's 2, or 2 over 1, its reciprocal function, sine, must be a half. I feel like we already did this one. Huh? We did sine negative a half. Okay, negative half is here at the pi over 6's, right? Now we just need sine is positive a half. Again, however you want to do it, whether you say, okay, I'm going to go up just a little bit, so just up a little bit, but over more, or you say, okay, opposite 1/2. Here's a triangle where the opposite is 1/2, the adjacent, that longer side, the root 3 over 2, 30-degree reference angle. Sine is positive in the first and the second quadrants. So I'm going to be talking about this 30-degree triangle created, that 30, 60, 90, shorter 30, 60, 90, that triangle, that 30, 60, 90. At the pi over 6 is located in the first and second quadrant. 1 pi over 6, 6 pi over 6, this is 5 pi over 6. What's great about these questions is that, notice your answers, the denominators are always the same. I can't even think about a question where like an answer is going to be a pi over 3 and a pi over 6 combined. You know, it's like you're pretty consistent with the angles that you need to create. Um, you are consistent with the angles you need to create. Therefore, your solutions have the same denominator. So that's good to know. You should never be looking at pi over 6 and a pi over 3. You're just making a mistake there. Okay, secant 2 root 3 over 3. What the heck? Well, secant's the reciprocal of cosine. If I flip this fraction, it's 3 over 2 root 3. What the heck is that? It's something that we'll see in a second. If I rationalize, multiply the top and bottom by root 3, since this is 2 times root 3 times 3, it's like 2 times 3 times 4. You can multiply the 3 and the 4. You don't distribute the 4 to the 2 and the 3. That doesn't make sense. Multiplication, you just do like 2 at a time and then multiply the other one. There's no distribution unless there's like an addition symbol. So why I say that is like 2 times root 3 times root 3 is just 2 times 3, 2 times root 3 squared. So I get 3 root 3 over 2 times root 3, or 3 times root 3 over 6. The 3's cancel, or the 3 over the 6 cancels to be 1 over 2. This is just root 3 over 2. So really, secant equaling 2 root 3 over 3 is the same as cosine equaling root 3 over 2. Cosine, adjacent, horizontal distance needs to be the longer distance that we see in a 30, 60, 90 triangle. That's on our short orientation. This guy, the 30-degree reference angle, creating the shorter 30, 60, 90 triangle. Here's the horizontal root 3 over 2, vertical 1/2. When is cosine positive? Cosine's positive here and here in the first and the fourth quadrants. So I want the 30-degree angle created here and the 30-degree angle created here. 30-degree angles, always pi over 6's. I could take those side lengths and put them here. That's going to be 1 pi over 6. Go all the way around the circle. 12 pi over 6 minus 1 pi over 6, 11 pi over 6. It's very important to know that like this 11 pi over 6 is coterminal with like negative pi over 6. If I just go 0 and subtract, like that's coterminal. I could go all the way around the circle, get to 12 pi over 6, add 1, and this is coterminal with 13 pi over 6. There are infinitely many solutions to all of these problems. But we are told from the get-go that we want our solutions between 0 and 2 pi, which means we're not looking for negative solutions, and we're not looking for solutions that are beyond 360 degrees or beyond 2 pi radians for now. But in the future, we might have to explore. So I'm just talking pi over 6 and 11 pi over 6. And by the future, I mean like later in this homework. All right, what happens here? Well, isolate your trig function. Subtract 2 and get sine is 1. Sine, vertical, when do I have a vertical distance on my unit circle, and what angle is the vertical distance 1? Well, that's when we just go straight up. To get to my unit circle, that has a radius of 1. How do I get that vertical distance? Boom. Straight up. Straight up, pi over 2. 90 degrees. Subtract 8, divide by 4. You don't have to show this. You can just do this. Make sure you subtract 8, divide by 4. It's negative 2. Did we do this one? Secant? Good. I'm doing a good job with this. I created this homework, so it's good that all the solutions or all the questions are a little bit different. So this is cosine. When does that equal negative a half? When is the adjacent side length a half? That's our tall 30, 60, 90 triangle. Shorter horizontal, longer vertical. Cosine is negative here and here in the second and the third quadrants. Sine's positive here, tangents. You can just say, okay, I want to go to the left a half. That's another thing you do. Here are my tall 30, 60, 90s with that horizontal side that is negative a half. So your tall orientation, 60 degrees, pi over 3 radians. We need this pi over 3 and this pi over 3. Start at 3 pi over 3, subtract 1, add 1. This is 2 pi over 3. This is 4 pi over 3. Okay, well, first I got to add 9 root 3s to both sides. You should probably see where this is going. Divide by 18. 9 over 18 simplifies to be 1 over 2. So this is just cosine equals root 3 over 2. I'm going to see if we already did. Cosine's equal to root 3 over 2. Here, adjacent is the longer side, the root 3 over 2. So I want the pi over 6's in this quadrant and this quadrant. Look at that. Did I not have a cosine root 3 over 2? This is great. Look at me. Wait, I do. Here it is. So here is what I'm looking. Cosine equaling root 3 over 2. Making sure I add, making sure this is positive. Getting this set of solutions, pi over 6 and 11 pi over 6. Here, the adjacent's longer. Here's the adjacent's longer. This is at a pi over 6. This is negative pi over 6, but we're looking between 0 and 2 pi, so we'll say that's 11 pi over 6. Same location, different angle. All right, cosine equaling sine. A lot of people are like, like when is the adjacent side length equal to the opposite side length? It's like, okay, it's at a pi over 4. A lot of people are like, okay, and cosine and sine have to be positive. So they're like, all right, pi over 4, and that's our answer. But that's not the only answer. They don't have to be positive. It's just when do they equal the same thing? One way to see this is to turn this into a similar equation that we've had where it's like a trig function equals a value. Watch what I'm going to do here. I'm going to divide both sides by cosine. And I get 1 equals sine over cosine. Hopefully you remember from the days that sine over cosine is the same as tangent. There's a quick reminder. Sine is opposite, cosine's adjacent, so tangent, opposite over adjacent, it's got to equal sine over cosine. So now the question is like tangent equals 1, and you're like, oh, the tangent equals 1 here at pi over 4. Yeah, but tangent's also positive here in the third quadrant. And you're like, but isn't sine and cosine negative in the third quadrant? Yeah, they are, but they're both negative. So sine and cosine equal each other here. You got either positive root 2 over 2, positive root 2 over 2, sine equals cosine. But here you got negative root 2 over 2, negative root 2 over 2, sine equals cosine. So I actually want this pi over 4 in the third quadrant. How do I get it? Start with pi, 4 pi over 4, add a pi over 4, you get 5 pi over 4. That's the same thing that happens here. A lot of people think, oh, sine has to be negative, cosine has to be positive, and they have to be the same value, but that's not the case. Like, what if I divided by cosine? This would be negative tangent equals 1. And then what if I just take the opposite of both sides, or multiply or divide both sides by negative 1? Now you have like, when is tangent negative 1? Well, tangent is negative in the second quadrant and the fourth quadrant. So what we're looking for actually are the pi over 4s, where the sine equals the cosine, where the vertical equals the horizontal, both in the second and the fourth quadrant. Okay? It's not just what people think, which is, oh, it's got to be the fourth quadrant. Sine's negative, cosine's positive. This pi over 4. No. We want this one because it's really saying when are sine and cosines opposites of each other. Take this, 45, 45, 90. This is negative root 2 over 2, and this would be positive root 2 over 2, right? Well, it's like, okay, so that'd be negative root 2 over 2 equals negative root 2 over 2. That works. That's balanced. This is the opposite of negative root 2 over 2. That's positive root 2 over 2. That's the sine value. Equals positive root 2 over 2. So just don't leave out answers. It's a common mistake. We want this pi over 4, which is 1 pi over 4 less than 4 pi over 4. And we want this pi over 4 here, which is 1 pi over 4 less than 8 pi's over 4, right? 8 divided by 4 is 2 pi. So this is 7 pi over 4. I feel like we already did this one. Yep. Skip it, or just write down the answers. There's my first mistake, Mr. Messner's first mistake when he created this homework. I probably copied down this previous row and then just forgot to change this. 5 pi over 6, 11 pi over 6. This would be good practice if you didn't do this one. Practice of figuring out the triangle's orientation, figuring out it's got to be 1/2 over root 3 over 2 to get the 1 over root 3, which then simplifies to be root 3 over 3 after you rationalize it. Opposite over adjacent, 1/2 times 2 over root 3. That turns into root 3 over 3. And then making sure you understand tangent's negative here and tangent's negative here. Second quadrant, fourth quadrant. These are repeated too. Ugh, lots of mistakes. Skip. You already did it. Maybe do for practice. The answers are up here. All right, but now I got some good ones. Whoa, what is going on? Is cosine squared? Sine squared? What? Well, we can think about this as like a quadratic equation. First things first, if you have a quadratic equation, know that you can't combine things. 2x squared plus x, 2x squared plus x. They're not like terms. They can't be combined to be 3x squareds, can't be combined to be 3x cubes. 2x squared times x is 2x cubed. But when you add, you just can't. They're not the same thing. I like to use fruit as a comparison. It's like types of fruit. You can't have apples and oranges and say you have apple oranges, or you say you have app squareds or something like that. But what would I have to do if you have x squareds and x's and you want to solve an equation? We like to factor. Factor out an x, like that. And then, since this is a product, and you have a product equal to 0, use the famous thing where it's like 0 times anything is 0. You have two equations you have to solve. You have like this piece equaling to 0, and then you have this piece equaling to 0, right? And then you solve both equations. You have like, this is easy. This, subtract 1 divided by 2, right? That's the same idea with these guys. But I'm not factoring out x. Like the x is trapped inside the cosine. What you do is factor out cos x. It's important to know that cos squared x is like cosine x quantity squared. It's just a shortcut so that we don't have to use parentheses. So I have cosine x times cosine x. I'm going to factor out one of the cosine x's from both of these terms. From the first one, I pull out one of them, I divide out one of them, I still have one left over with that 2. Divided out of the second term, cosine divided by cosine is 1. Think about if I distributed this in, just to kind of like undo what I just did. Cosine x times 2 cosine x, boom, 2 times cosine x quantity squared, or 2 cos squared x. Cosine x times 1 cosine x. Okay? Now I've set up this product equal to 0. I have 2 different pieces that could equal 0. As long as a piece of the product equals 0, everything equals 0. So we got 2 equations. Cos x equals 0, 2 cos x plus 1 equals 0. Why don't we make this equation that I can solve by subtracting 1 divided by 2? I get that. Okay? So now 2 different problems, all coming from this one problem. When does cosine equal 0? Okay, cosine equals 0 when I'm going up or down, but I'm not going left or right at all. Right? So when is my adjacent, my x distance 0? It's up here at pi over 2, and it's down here at 3 pi over 2. It's good practice for our like extremes. So those are 2 of our solutions. But now I have this solution as well. When is cosine equal to negative a half? So I want my tall 30, 60, 90 triangle located here when the x distance is negative, and the tall 30, 60, 90 located here when my x distance is negative. That's because 1/2 is the shorter side of our 30, 60, 90 triangle. I want the shorter side to be the horizontal, cosine adjacent horizontal. Some of you are probably like all over this. Some of you need to like figure it out in your head and be able to do it by yourself. So this is our 60-degree reference angle. So our taller, it's our pi over 3s. If this is 3 pi over 3, this is going to be 2 pi over 3, 4 pi over 3, giving us 1, 2, 3, 4 possible solutions for x for this one equation. If you want to practice, you can list them off in order from smallest angle to biggest angle. Okay? Same thing for this guy. Sine times sine minus sine. Factor out a sine. From the first guy, we're left with just one sine. From the second guy, it's gone, just have a 1. 2 equations that we have to solve. When is sine 0? And when does sine x minus 1 equal 0? Solve that for sine, you get sine is equal to 1. Okay, when does sine equal 0? That's when my vertical distance on my unit circle is 0. My vertical distance equaling 0 is here and here. Now, what is this angle measurement? Well, it's 0, right? But it's also 2 pi. 0 and 2 pi are included in our interval. We're looking for all of our solutions between, and since we have these closed brackets, it's not just between, it's between and including. Closed brackets means include. So we have 0 and 2 pi from the one on the left one, as well as this one over here, pi. So 0 pi, 2 pi. And then when does sine equal 1? We did that before. That's at pi over 2, vertical distance. If sine equaled negative 1, I'd be down here at 3 pi over 2. Okay? You want practice, you would say x equals 0. Pi over 2 would be next. Pi is next, not 3 pi over 2, because the sine of 3 pi over 2 is negative 1. I want when sine is positive 1. So we exclude 3 pi over 2 and include 2 pi. This is fun. Factor out a tangent. What do we have left over? A root 3 tangent and a 1. Okay, so two solutions. One is tangent equal to 0. We'll have to think about that. And one is root 3 tangent minus 1 equal to 0. Okay, tangent. Opposite over adjacent. Vertical over horizontal. I want vertical over horizontal to be in this form. 0 on the top divided by 1. I don't want 1 over 0. If it's 1 over 0, that's undefined. That's not going to be a solution. It's got to be 0. That means I want our angles where my vertical is 0 and my horizontal is anything else. It could be 0, it could be 1, it could be anything, any sort of number, as long as my vertical is 0. Also, we don't want 0 over 0. We can't do that either. That's undefined. You may think that's like 1 or something, or it's 0, but you just can't. 0 over 0, you can't do. So, what is my vertical distance 0? Here and here. The horizontal distance is 1 over here. The horizontal distance is -1 here. So that gives me the same locations as when sine 0 from this one, 0 pi and 2 pi. Okay, so I got this equation solved. Now I got to do this one. I'm going to add 1 and divide by root 3. So I'm looking at when tangent x equals 1 over root 3. Okay, we've seen this one before because if you rationalize it, it's root 3 over 3. This would be good practice if you'd like to, do this yourself. You got to figure out which triangle's orientation does opposite over adjacent give us 1 over root 3. Let's think. If it's root 3 over 2 divided by a half, root 3 over 2 divided by a half, that's going to be root 3, right? Root 3 over 2, the longer, divided by the shorter, 1/2. Root 3. Okay, that's not what I want. So what's the other orientation? This one. 1/2 is the opposite, the adjacent root 3 over 2. 1/2 times 2 over root 3. Boom. 1 over root 3. This one. I need this one. I need when tangent's positive. Tangent's positive here. Tangent's positive here. This shorter triangle. This. That shorter triangle. Can't go left. Only turn right. All right, that one. 30-degree, right? Shorter. Pi over 6 creates the 30-degree angles. That's pi over 6. This would be 6 pi over 6. Add the pi over 6. Counterclockwise is adding 7 pi over 6. Ooh, look at that. 5 solutions. So let's list them off in order. I got 0, pi over 6, pi, 7 pi over 6, all the way over to 2 pi. All right. Now, bad formatting. My bad. We want to find all solutions for the given interval, but careful. I may have to find more or less than just 2 solutions because for each of these, I have different intervals. First one, piece of cake, 0 to 2 pi. But the second one, I have like 0 to 4. What's that mean? And also, what else is going on here that we're not used to? 5x over 6 inside the cosine. How do we handle this? First things first, you can't remove the 6 and the 5. A lot of people are like, oh, can't you just like divide by 5/6 or multiply by 6/5 and then like that goes away? No. Order of operations like functions, which include like exponents and stuff like that. It should, instead of PEMDAS, parentheses, exponents, it should be like PEMDAS with an F in there. Functions would need to be gotten rid of last. I'd have to get rid of the cosine to be able to get rid of the the 5 and the 6. You can't do this unless the cosine was gone. Okay? Cosine takes precedence. The cosine is trapping the 5x over the 6 in its clutches. You'd have to get rid of the cosine if you wanted to do anything to the 5 or the 6. So get that out of your brain. We got an alternate approach. Here's my alternate approach. Is to just change what's inside. Instead of like 5x over 6, just say like, that's just something else. Like, and make it a simple question that we were just doing. When is cosine equal to negative a half? Okay, and let's find our solutions for y. Okay, cosine, negative a half, cosine adjacent, horizontal. The half is the shorter side. I want the horizontal to be the shorter side. So that's my 60-degree angle, horizontal, that guy. Okay, so that's a pi over 3. One is cosine negative. Cosine's negative here in the second quadrant and here in the third quadrant. So I want the pi over 3 here, and I want the pi over 3 here. Now, your solutions for y are not what we're looking for. I want the solutions for x that are between 0 and 2 pi. Keep that in mind. So when I say, okay, that's 2 pi over 3, which is 1 pi over 3 less than 3 pi over 3, and that's 4 pi over 3, and I write those down, those are not the solutions that I'm looking for. These are not my answers. I want the solutions for x, and I want when x is between 0 and 2 pi. Okay, that's very important. Well, how do I get my solutions for x? Ready? We took this y and we replaced all the stuff inside of here with y. So if I have my solutions for y, I realize, okay, well, y is the same as 5x over 6. So I'm just going to like re-replace y. And now I have something where it's like, oh, there's no longer cosine. It's like y was my angle that I was finding, and my angle is 5x over 6. Boom, I got that. Cosine's gone. Now I can get rid of the 6/5, or the 5/6. Well, how? You can either divide by 5/6. I like to multiply. So I'm going to take that, and I'm going to take all of these and multiply it by 6/5. Now the 6, the 5s are just 1s. 6 over 6 is 1, 5 over 5 is 1, giving me x equals. Now, what do I do when I multiply like this by 6/5? Well, it's like 12/15, or the 6 and the 3 cancel to just be 2. So I get 4 pi over 5. 12/15 is like 4/5. 4 pi over 5. Okay. Now we look at this guy and we think, is this guy between 0 and 2 pi? It is. It checks out. Good. Let's do the same thing here. 6 over 5. You can either say it's 24/15 and then divide the top and bottom by 3, or cancel the 6 and the 3 to make it a 2 and a 1. 8 over 5. Now we look at this solution and you say, is this between 0 and 2 pi? It is. Keep it. That's good. However, moving forward for the next couple problems, we might find that if we went around the circle again and ended up at this location, got an angle that might not start between 0 and 2 pi, but after manipulating it would end up between 0 and 2 pi, that's what we have to worry about now. So we're not just stuck originally from 0 to 2 pi, because we will manipulate those angles to get our solutions for x. It might be confusing, but like, let me show you here. Like, okay, this is 2 pi over 3, sure. But couldn't I just add 2 pi to this, go around the circle, and end up right where, I was at 2 pi over 3, just with a different angle, a cooler angle, because you go around the circle again to get there. So it's like 2 pi over 3. I'm going to add 2 pi, add 6 pi over 3, and I realize, oh, this is 8 pi over 3 as well. So 2 pi over 3 is the same location as 8 pi over 3. Now, how did I do that? I turned this into something that looks the same so that I can add two fractions together, common denominator. Okay, I'm going to go over here and say, like, well, what if I had 8 pi over 3? Same location, but a different angle. I just took that and added 2 pi. What if I took that and multiplied it by 6/5? Could this be between 0 and 2 pi? Well, you'll find out quickly it's not. This turns into a 1. This turns into 2. It's 16 pi over 5 after multiplying by 6/5. And I realized like 16 over 5 is definitely bigger than 2. So 16 pi over 5 is bigger than 2 pi. So this is not a solution. You might be like, Mr. Messer, why did we do this? Like, this is pointless. I found my two solutions. I manipulated them, and I have two solutions that work. I'm going to show you in a second why we just did that. Okay? I'm looking for solutions between 0 and 4. What? Sine pi x over 4? What? Don't freak out. Start with just like simple equation. Trig function equal to a ratio. When is sine equal to a half? All right, we've done this before. 30-degree reference angle, vertical side's a half. Sine is positive in the first quadrant and in the second quadrant. So I want the shorter 30, 60, 90, so that my vertical side is the shorter side 1/2. Okay, so I'm right here, and I'm right here. Cool. This is at pi over 6's, right? 30-degree reference angle. So this 30-degree reference angle, this is pi over 6. 6 pi over 6 minus pi over 6, 5 pi over 6. Okay, so I found two solutions right now for y that are between 0 and what I'm used to is 2 pi. But now it's like 0 to 4. It's like, what? Don't worry, watch what happens. Y gets replaced. We replaced pi x over 4 with y. So let's go back and re-replace it with pi x over 4. How do I solve for x? Get rid of the 4, get rid of the pi, multiply by the reciprocal. Don't divide by a fraction. It's messy. So I'm going to multiply all these by 4 over pi. All right, so let's do the first one, 4 over pi. All right, 4 times pi times 6. The pi's go away. 4 divided by 6 gives me 2 over 3. Okay, 2 over 3 is between 0 and 4. It's a number that looks nice. It makes sense if you have an interval from 0 to 4. That works. Take pi times 2, take 4 times 3. That would give you 2 pi over 12, turns into pi over 6. That's why it works. That's how we get our answer. It's like 2/3 times this gives me pi over 6. Let's take 5 pi over 6 and multiply it by 4 over pi. So maybe we can cancel the 4 over 6 and make it 2 over 3. That's easy. Giving us our answer 5/3 because the pi's cancel. 5/3, not even 2 yet. Is it between 0 and 4? Yes, it is. We think, great, I got my two solutions. But here is where things are going to be a little bit more complicated because guess what? If I went around the circle again and ended up at this location, it's like adding 2 pi to pi over 6. Well, how do you add 2 pi to pi over 6? Well, 12 pi over 6 is 2 pi. That gives me to 13 pi over 6, okay? Watch what happens when you multiply this by 4 over pi. That turns into 2. That turns into 3. 2 times 13 is 26. The pi's cancel. 26 thirds. Is that between 0 and 4? Actually, no, it's not. I'm getting you ready to go around the circle for one of these questions, but not yet. This is it. Trying to make sure I did everything correctly. Yeah, I didn't do this correctly. This is not 5 pi over 3. 2 times 5 is 10. 10 over 3. 10 over 3, 3, 6, 9. That is close to 4. 4 would be 12 over 3. 10 over 3 is good. I'm checking because I might have to do it, but for this situation, no. I kind of gave you an interval to give you the correct solutions. But let's be ready. Here we go. Let's be ready. Cosine x over 2 equals root 3 over 2. There's my thing on the next page. Turn into just when is cosine? For what angles? Y? Does cosine equal negative root 3 over 2? When is my adjacent side length root 3 over 2? It's when I have my shorter 30, 60, 90 triangle, where the adjacent side, the longer side, is the root 3 over 2. This is at a pi over 6, shorter. So I want the pi over 6 here and the pi over 6 there, because that's when cosine is negative, when I'm going to the left. All right. 5 pi over 6, 1 pi over 6 less than 6 pi over 6, 7 pi over 6, 1 pi over 6 more than 6 pi over 6. So we start with y. Those first two are between 0 and 2 pi. But hold the phone. What happens if I find my solutions for x? Okay, well, I replaced x over 2 with y, so let's re-replace and let's solve for x. What does x equal? That's the goal. Multiply by 2. Okay, so when I multiply this by 2, and when I multiply this by 2, what happens? Ready? This is 10 pi over 6. This is 14 pi over 6. Now, on the previous problems, I kept going because I have to prepare you to keep going. This problem, I know I don't have to keep going. You know why? Because I know this one, 14 pi over 6. 14 over 6 is bigger than 2. 14 over 7 is 2. 14 over 6 is going to be like 2 point something. You know, it's 2 and 2/6 or 2 and a third. So actually, you want something between 0 and 2 pi? This is not between 0 and 2 pi. That's bigger than 2 pi. It's gone. I just want this. Now, what I probably should have done is simplify that. 10 pi over 6 to be 5 pi over 3. That's already close to 2 pi. This is 7 pi over 3. 7 pi over 3 is bigger than 2 pi. 7 over 3 is bigger than 2. So 7 pi over 3 is bigger than 2 pi. I don't want that. The only solution on our interval is 5 pi over 3. This is just like, it's a little bit more complicated. You know, it's not as simple. Let's see. 3 pi x. I know I'm going to be looking for more than just the first two that I find. Replace 3 pi x with y. I'm looking for solutions between 0 and 2. When is sine negative root 3 over 2? Sine root 3 over 2, tall, opposite, the longer side. This is at the pi over 3's, 60-degree angles. When is sine negative? Sine's negative in the third and the fourth quadrant. So I want the pi over 3 here and the pi over 3 here, where my vertical side lengths are negative. I might need more than just one pi over 3 here and here. Might need more than just one angle. I might have to go around my circle again. But let's start off. This is 3 pi over 3. This will be 4 pi over 3. Add another 60 degrees. That's 5 pi over 3. Or you can go 6 pi over 3, subtract. So I'm starting with two solutions for y, but let's see if we might need more for x. Y is 4 pi over 3 or 5 pi over 3 to start. But I'm looking for solutions for x. I need to take both of these, divide it by 3 and pi. You could also say multiply by 1 over 3 pi. That might be easier to see. Now, the 3's, or the multiplying, goes across the bottom. So let me show you. 1 over 3 pi. The pi's cancel, but it's not the 3's cancel. The 3's get multiplied by each other, giving me 4/9. Here, 1 over 3 pi. Pi's cancel, but the 3's multiply. They don't cancel because they're in the same spot. 5/9. Okay. Are those between 0 and 2? Definitely. But let's keep investigating. We might have to look around the circle again where 4 pi is. I need to take 4 pi, add another 2 pi, go around the circle. 4 pi over 3, add another 2 pi. That's like adding 6 pi's over 3. 2 pi is going around the circle. You can write 2 as 6 over 3. Gives me to 10 pi over 3. 10 pi over 3, same location as 4 pi over 3. What happens if I multiply this by 1 over 3 pi? I get 10/9. 10/9, finally, is a number between 0 and 2. 10/9 is a solution for x. Keep it. 5 pi over 3. Add 2 pi to get the same location but a different angle. 5 pi over 3 plus 2 pi is like plus 6 pi over 3, giving me 11 pi over 3s. Divide by 3 pi, it turns into 11/9. Is that between 0 and 2? Yes. I'd have to get to 18/9. So, guess what? Let's keep going. I'm not sure. Let's take 10 pi over 3, add 2 pi to that. So, adding 6 pi gives me 16 pi over 3. 16 pi over 3 divided by 3 pi. 16 over 9. Is that between 0 and 2? Yep. Add 2 pi to 11 pi over 3. Add 2 pi to 11 pi over 3. That's adding 6 pi over 3. That's 17 pi over 3. Divide that by 3 pi. 17/9. That's good. Now, you could probably guess it's like, okay, I'm really close to 2. I'm probably good here to stop, but be just careful. Try one more. Add 2 pi. Adding 6 pi's over 3. 22 pi's over 3. 22 over 9. Pi's go away. 22 over 9 is bigger than 2. I got to get to 18. So we are used to just having 2 solutions. Maybe if you factor something out, you might have more than 2. But look, 1, 2, 3, 4, 5, 6 solutions for this. Only 1 solution for this. We need to be prepared. 4 more. I can do this. All right, secant equal to 2. Change it to cosine. Cosine equal to 1/2. I'm going to breeze through the beginning parts. Cosine equal to 1/2. Tall in the first and the fourth. What are those angles? Pi over 3. 5 pi over 3. It's 1 pi over 3 less than 6 pi over 3. What am I looking for? X, though. X over 4 is what was replaced by y. I want to solve this for x. I'm looking for solutions between 0 and 2 pi. To solve for x, multiply by 4. When I multiply pi over 3 by 4, I get 4 pi over 3. When I multiply 5 pi over 3 by 4, I get 20 pi over 3. 20 over 3, bigger than 2. I'm not including that. I had to reduce the solution. Sine equaling 1. Looking from -1 to 1. That's interesting. So because I see this, I'm like immediately thinking, okay, I got to be careful. 1 is sine equal to 1 at pi over 2. Right here. I'm also going to say that's at -3 pi over 2. -1, -2, -3 pi over 2. I'm just going to be careful. I'm going to include that one as well. -3 pi over 2, not at +3 pi over 2, because that's when sine's negative. And I'm sorry that I didn't have an example where like sine equals -1, but you should know that. So 4 pi x divide by 4 pi or multiply by 1 over 4 pi. 1 over 4 pi. 1 over 4 pi gives me x solutions that are pi's cancel, 1/8. Pi's cancel. 4 times 2 is 8. -3/8. -3/8. Oh, that's between -1 and 1. That's included. How did I know to go to -3 pi over 2? I'm like, I just had to think. It's like, if I just had 1/8, I would have been comfortable. If I kept going around this way, maybe I need to. If you take pi over 2, add 2 pi, adding 4 pi over 2, you get 5 pi over 2. Divide that by 4. Oh my goodness, look at this. 5/8. Oh, that's between -1 and 1. I probably need to keep going in the negative direction. I'm not going to add 2 pi to -3 pi over 2. I'm going to subtract 2 pi. So -3, -4, -5, -6, -7 pi over 2, or add -4 pi over 2 to -3 pi over 2, -7 pi over 2. Oh my goodness, look at that. Divide by 4 pi, -7/8. The pi's are gone. That's between -1 and 1. I have 4 solutions. Let's see if I can find another one. 5 pi over 2 plus another 4 pi over 2 gives me 9 pi over 2. 4 pi over 2 is the same as 2 pi. Divide that by 4 pi. That gives me 9/8. Nope, that's out. Okay, these are tricky, but you got to be ready. What I do on like your tests is I ask you like, how many solutions are there for this equation in this interval? And you have to answer, oh, there's 4 solutions, which means you have to find all 4 of them. All right, sine equaling -1/2. Here and here, I'm going down 1/2. That's the 30, 60, 90 when sine's opposite. I'm looking from -6 to 10. Wow. There we go. Sine opposite. Opposite's going to be the shorter side if you have a 30-degree reference angle, pi over 6. My first two that I find are 7 pi over 6, which is 1 pi over 6 more than 6 pi over 6, and 11 pi over 6. Okay? But I'm looking for this. I know immediately, since this is -6 to 10, that I probably need to go in the opposite direction, which means I probably need to include this angle location, which is -pi over 6. How do I know that? You can take 11 pi over 6 and subtract 2 pi, subtracting 12 pi over 6s, or know that this is 0 pi over 6, subtract a pi over 6. What's this one in terms of negatives? Well, its original location was 7 pi over 6. If I subtract 2 pi, that's like subtracting 12 pi over 6. -12 plus 7 ends up being -5. I'm going to include that. Okay? We're going to start with 4 positives and negatives. I might have to take 7 pi over 6 and go around and say, okay, 7 pi over 6 is also 19 pi over 6. How did I get that? I added 2 pi. 11 pi over 6, add 12, that's 23 pi over 6s. How did I go? I added 2 pi. This is also the same location as -pi over 6. This is also the same location as -5 pi over 6. You can go to -6 pi over 6, add a pi over 6. Anyways, I want my solutions for x. I'm going to take everything and multiply it by 6. What? This should be a pi right here. I apologize. I wanted this to be, a pi in the top, pi x over 6. The reason behind that is so that you would also divide by pi. So when you do that for all of them, the pi's would go away. All the pi's are gone. And then when you multiply by 6, all the 6's in the denominator go away. Gone. 7. That's good. Gone. 11. Not good. Gone. -1. Good. Gone. -5. Good. 7, -1, -5. Tricky stuff. Last one. 1 does tangent equal -√3/3. We've done this before. I think yeah. Is it negative? I've done it a lot of times. 5 pi over 6, 11 pi over 6. Do it for practice if you don't know why. 1/2 divided by √3/2. When is it negative? Second and the fourth quadrant. All I need to do to solve is to divide by pi or multiply by 1 over pi. Giving me solutions for x of 5/6, 11/6. 11/6 is close to 2. I'm looking at 0. The first one has got to be this one. I know I don't have to add or subtract solutions, so I'm kind of done right there. Don't think you did much of this last year at all, so this is all new to everybody. But it's a good way to understanding that angles don't start and stop between 0 and 360 degrees. You can go negative angles, or you can go around the circle more. And this is a way to kind of show you how to get those angles, manipulate those angles to get solutions. A lot of times in this class, you will see not just the sine of x. You'll see the sine of 4 pi x. You'll see the sine of cosine of x over 2. So I need you to get comfortable with this, the way of looking at trig functions this way, because this is what you see often in this class. Okay, that's the homework video. Good luck on everything. Come in with questions. I'm sure we'll practice this bunch more than the other bunch when we come back.